Hello, this is Mr. Best. Welcome to Chapter 4, Closure, questions 122 to 131. Question 122. Solve the missing side length or angle below. Part A, we have a right triangle, so we can use our tangent ratio. Tangent of 40 degrees is equal to the opposite side length, which would be x, or delta y, over the adjacent side, or delta x, which would be 11. We can go ahead and solve that, and we will get x is approximately 9.23, and that would be in meters. Part B, once again, our tangent ratio, tangent of 52 degrees is equal to 7 over x. Now on this one, be careful because x is your denominator. So you have to kind of do this one in two steps where you multiply by the x. And then you will have to divide by tangent of 52 degrees. Or whatever the approximation you use for tangent of 52. And you will get x is approximately 5.47 meters. And then on to part C. Now this one we have tangent of some angle, which we're going to call theta, is equal to the ratio of 5 over 5. Or tangent of theta is equal to 1. So you might have to go back to your toolkit and take a look, unless you remember what angle gave us a value of 1. But think about your slope. The slope ratio is 1. What angle, when you graph something, has a slope of 1? And that would be 45 degrees. So theta is equal to 45 degrees. Question 123, use a flow chart to show how you know the triangles are similar. Then find the value of each variable. So we will start with part A here. We have 32 degrees and 32 degrees. We're missing a couple angles here, so let's use our triangle angle sum theorem and take 180 minus the two angles to find the third one. And that will make this angle right here, angle F, 62 degrees. And so now you can see F is congruent to angle C. So we know at this point that the triangles are similar by the angle-angle similarity. And that means we could also find value x now because these sides are in proportion. Let's go ahead and set up our flowchart proof first, and then we'll find the value of x. Alright, so there's the flowchart. Now let's go ahead and find the value of x using that the side lengths are in proportion. So we'll just, we know we need EF for sure, so we'll just go EF, which would be x over. EF matches up with BC, so that'd be 2.4. And then we need to make sure we have side AB as well, and AB matches up with DE, so that would be 6 over 4. And we can go ahead and solve for x. And so x is equal to 3.6. Now let's look at B. So we're looking at this triangle compared to the bigger triangle here. So those are the two triangles. So if you want to separate them, you can, so you can look at both of them. Angle D and angle E are congruent. We also know that angle C, it's the same in both triangles, so it's congruent to itself. So once again, angle-angle similarity, we know that the triangles are similar. So let's go ahead and create our flowchart. And so similar to the one above, now we can also find the value of x, once again knowing that the side lengths are in proportion. So we will say that side BD, which is 3, is in proportion with AE, so that's x, and that will be equal to, this side length of the smaller triangle is 5, and then make sure you do the entire side CA, which is not 2, but it's 7. You got 5 plus 2. So now you can go ahead and solve for x. And so x is equal to 4.2. Question 124. Salvador has a hot dog stand 58 meters from the base of the Space Needle in Seattle. He prefers to work in the shade and knows that he can calculate when his hot dog stand will be in the shade if he knows the height of the Space Needle. To measure its height, Salvador stands at the hot dog stand, gets out his clinometer, and measures the angle to the top of the Space Needle to be 80 degrees. Salvador's eyes are 1.5 meters above the ground, assuming that the ground level is between the hot dog stand and the Space Needle. Assuming that the ground is level between the hot dog stand and the Space Needle, how tall is the Space Needle? Now, the picture was not on there for you, so went ahead and put it on here so that you could kind of see what this is going to look like. We do know that this height is 1.5 meters, which you see right here as well. Obviously, the picture is not drawn to scale. You have 80 degrees, and we're looking for this height, and then we'll add on the additional 1.5 meters at the end to get the total height. So we can use our tangent ratio because we are dealing with a right triangle. So tangent of 80 degrees is equal to h over the 58 meters that the hot dog stand is from the base of the Space Needle. And then we can go ahead and solve for h, and that would be 58 times whatever the tangent of 80 degrees is equal to. Therefore, h is approximately 329 meters. And then if we add on the additional 1.5 meters, we're going to have a total of 330.5 meters. So don't forget to make sure you answer the question that is being asked. Question 125, use the diagram below to answer the questions below. Part A, state the name of the geometric relationship between the angles below. Also describe the relationship between the angle measures if one exists. Alright, so angle A and then angle H. Knowing that these lines are parallel, A and H would be corresponding angles, and we know that corresponding angles are congruent. Alright, next we have B and E. So B and then E is right here. And those would be straight angle pair, and we know straight angle pairs are supplementary. Number 3, C and G. So we have C and then we have G. And once again, because of the parallel lines, those angles are alternate interior angles, and we know they are congruent. The fourth one, G, D, H. So G, D, and H, and those are 3 angles of a triangle. So that would be the triangle Sum Theorem, and we know that they add up to 180 degrees. All right, part B, find the measure of each angle listed below and justify your answer. Let the measure of angle C equals 32 degrees. So I'm going to go ahead and put that in up here. So that's 32 degrees. And the measure of angle E is 55 degrees. So we know that's 55 degrees. All right, now that we know that, we're looking for angle J. So angle J. Angle J and angle E, based on the parallel lines, are corresponding. So we know angle J is 55 degrees. All right, and now we're on to angle D. So I'm going to go ahead and put J in there at 55. That might help us as we go through the rest of these. Angle D. Now angle D is going to form a straight angle with C and E. So we know it's going to be 180 minus those two. All right, now we have next one, number 3, the measure of angle A. So angle A, let me go ahead and mark D. D is 93. And then angle A is right here. And so with these 2 lines, this one and this one, A and E would be vertical angles, and they would be congruent. All right, and then the last one, the measure of angle G, and that's right down here. And angle G and angle C are alternate interior angles, and they would be congruent. So angle G would be 32 degrees. And that is it for that question. Question 126. Draw a pair of axes in the center of a half sheet of graph paper. Then draw the figure below and perform the indicated transformations. For each transformation, label the resulting image A prime, B prime, C prime, D prime, and E prime. And so I've labeled the coordinates A, B, C, D, and E. Probably the easiest thing to do is get out tracing paper. You're going to rotate it 180 degrees clockwise. And then once again, really just look at the closure answer key at the back to double check your answers. It's going to be hard for me to show those rotations. So once again, use a tracing paper to do that, and you're going to rotate it 180 degrees clockwise for the first one. And remember, probably a good thing to do is to put a kind of mark right here at the origin, and then when you rotate it, make sure you're rotating 180 degrees, which would be a half a turn. 90 degrees would be a quarter of a turn, and from there. On part C, when you reflect ABCD across the y-axis, so you'd be reflecting across this line, and this point C you would reflect, you just count 1, 2, 1, 2, so then point C would be over here when you're reflecting across the y-axis. And then on D, when you translate it, you're just going to count up 5 and to the left 7 on all the points to find the new ones. So once again, probably the easiest thing to do, check your answers at the end of the closure problems on that one, and use tracing paper for A and B for sure. And then C, once again, count from the y-axis, and then D, you'll just have to count in both directions. Question 127. Kiyomi has 4 pairs of pants, black, peach, gray, and cream, and she has 5 shirts, white, red, teal, black, and lavender. If any shirt can be worn with any pair of pants, represent the sample space of all the possible outfits with both a probability area model and a tree diagram. How many outfits does she have? So you can see below, I took basically the answer out of the book that you can also see in the back of the closure problems, and created the sample space. So you have all the possible shirts up here, and then the pants on the side. So you can see that there are a possible of 20 different outfits that she could wear. And remember, if you have black, peach, gray, or cream, you have 1/4, and then white, red, teal, black, or lavender, you have 1/5. So out of all the possibilities on each of these, that's 1 out of 20. And the same thing happens with the area model as well, that each one of these would be 1/5, each one of these would be 1/4, so everything on here is 1 out of 20. Now on part B, it says the closet light is burnout. So Kiyomi must randomly select a pair of pants and a shirt. What is the probability that she will wear something that is black? So I'm going to use the area model for this one. So something that is black, let me change that to yellow. Alright, something that's black, so all of this column has black shirt, and then this row has black pants. So you can see that you're going to have 1, 2, 3, 4, 5, 6, 7, 8 possibilities out of 20. So 8 out of 20, and if you want to reduce that, you can reduce it by 4, or 2 out of 5, or 40% chance that she will have something black on. Question 128. In a certain town, 45% of the population has dimples and 70% has a widow's peak, a condition where the hairline above the forehead makes a V. Assuming these physical traits are independently distributed, what is the probability that a randomly selected person has both dimples and a widow's peak? What is the probability that he or she will have neither? Use a probability area model or a tree diagram to represent the situation. So I went ahead and decided to set up the area model for this one. I put dimples on top, yes, 0.45, no, 0.55. Remember that has to add up to 1. And then widow peaks on the left, yes, 70%, so 0.70, or no, 30%, 0.30. And then I'm going to go ahead and multiply those together to figure out, to finish off the area model. So as you can see, I went ahead and finished off the area model. Now to answer the question, what is the probability that a randomly selected person has both dimples and a widow's peak? So where on the area model does it show us both dimples and the widow's peak? Yes, for both of them, and that would be right here. So 31.5% chance. And then for the next part, It wants to know what the probability is that they will have neither. So neither, no, that would be this one, 0.165, which would be 16.5%. So once again, make sure you create the area model or the tree diagram. It doesn't matter which one, but then answer the two questions. Probability that they will have neither and the probability that they will have both. Question 129, trace each figure onto your paper and label the sides with the given measurements. On your paper, draw a height that corresponds to the labeled base for each figure. So the first one, that would represent the height of the triangle if the base is 3. With the rectangle, it would be the width as well, but the height would be the side length of the rectangle. For the parallelogram, the height is similar to what you're looking at in the rectangle as well. The distance between the two parallel lines when the base is 11 there. And then the trapezoid, kind of the same idea here. That would represent your height. So on part B, assuming that the height of each figure is 7 inches, add this information to your diagrams and find the area of each figure. So for part B, we're looking at, I'll just call this figure 1, 2, 3, and 4. So for figure 1, the area is equal to 1/2 base times the height, if we're talking about 7 inches as the height. And so our area is going to be 21 times 1/2, or 10.5 inches squared. On the next one, figure 2, it's a rectangle, so that would just be length times width, or base times height, if you want to look at it that way. And that would be 10 times 7. So on this one, that would be 70 inches squared. On figure 3, we're looking at a parallelogram. And the parallelogram does have an area base times height, where the rectangle typically is length times width. So on this one, we have a base of 11. The height is 7. So our area is 77 inches squared. And then the last figure 4, the area of a trapezoid is 1/2 times the height, and then the sum of the bases. So that's 1/2 times 7, and then the bases are 12 plus 8. So we will get an area of 1/2 times 7 times 20, and that would be 70 inches squared. Question 130, find the perimeter of each shape below. Assume the diagram in part B is a parallelogram. All right, find the perimeter. So we have to find the side lengths and then add them all up. So since this is 45 degrees, that means this side over here is 45, and that is 7 millimeters as well. They would have to be the same. So then we can use Pythagorean theorem. 7 squared plus 7 squared is, let's call this x, is equal to x squared. 49 plus 49, and that would be 98, and then you can take the square root of 98, and that would be approximately 9.9, so therefore the perimeter is 7 plus 9.9 approximately, and then the perimeter would be approximately equal to 23.9 millimeters. Part B, we're looking at a parallelogram as it states in the directions. So we want to find this part of the triangle. If this whole thing is 30 and then this is 18, then it represents that this would be 12 units to make up that 30. So we have 12 and 9, and then we have to figure out what that side is. So once again, we can use Pythagorean theorem. 9 squared plus 12 squared is equal to x squared. 81 plus 144. So 225 is equal to x squared. Take the square root of both sides and you get x equals 15. So that's 15 and 15. So the perimeter would be 18 times 2 plus 15 times 2. 36 plus 30, 66 meters. Question C. So we're looking for the perimeter. Let's kind of go around the figure and write down what it is that we do know. So we have 11 plus 6 plus 7. We don't know this side yet, and we also don't know this side yet. So how are we going to break that up to be able to figure out what those side lengths are? Well, you might recognize this as being a rectangle and a triangle. And so those two parts are part of the triangle. We don't have necessarily anything yet, but if we know this is 7 on top here and this total distance is 11, then we do know, I'm just going to cross off that 11, that means this would have to be 4 inches, and then that part right there would be a 7. That would give us a total of 11. So knowing that, we can use our tangent ratio. Tangent of 60 degrees is equal to this whole length right here, which I'm just going to say is y, over the change of x, which is 4. My 4's and y's, sorry, look sometimes the same. So we can use tangent of 60, and we can multiply both sides by 4. That will isolate the y value. And y is equal to whatever 4 times tangent of 60 degrees is. So let's plug that in the calculator and see what we get. 4 times tangent of 60 will give us approximately 6.9282. So that's the y value, but really, remember when we go back here, we don't need all of that. We just need that little piece. But if this is 6 over here, and then the whole thing is 6.982, or 6.9282, then that means this little piece right here that we didn't have, we now know is approximately 6.9282 minus 6, which would be 0.9282. So we're still missing the hypotenuse of the triangle. So let's now find that out now that we have the two legs. So we're going to use the length of the first leg, 4 squared, plus approximately 6.9282 was the full length. Squared is equal to, and I'll just call that x squared. So we get 16 plus, and if you square that, you will get 48. It's approximately 47.999955, whatever. If you plug in the whole thing and square it, you actually do get 48, so that's good. 16 plus 48 is 64. Take the square root of both sides, and x is equal to 8. So now we know that the last side that was missing for the perimeter is 8. So if we go back and fill in our last missing pieces, plus 0.9282 plus 8, we get a perimeter of 32. We'll round to the nearest hundredth, 93, and this is in inches. Question 131. For each equation below, solve for x. Went ahead and set up part A. X divided by 23 is equal to 15 over 7. Lots of different ways that we could solve this. I know some of you have learned cross multiplying. Also that we could multiply by the common denominator of 23 and 7, so maybe 23 times 7. I'm going to look at it a little different. I'm going to look at it as 7 times what gives me 23. And I can work backwards to figure out what that value is by taking 23 divided by 7 on my calculator. And I'm only going to write the approximation, but I'm going to use the whole thing in my calculator, 3.2857, so on. And what that means is that if I take 7 times that number, I get 23. So therefore, if I take 15 times that same number, then I should get what x is. And therefore, x will be equal to approximately whatever 15 times that number. Now, I'm not going to use 3.2857. I'm going to use the number that's in my calculator to get the most accurate answer. And I'm going to get a value of x equal to approximately 49.2 9 rounded to the nearest hundredth. And so once again, that's maybe a little different than what you thought, and that's perfectly fine. There's plenty of ways to solve equations and different ways to look at things. On part B, we have a binomial times a binomial equal to a quadratic, so we can use our generic rectangle to help us solve that, or at least to multiply the binomials. So we have x plus 2 times x minus 5. That'd be x squared minus 3x minus 10. You could also use the distributive property if you're not going to use the generic rectangle to multiply. And that would look like this. Either way, it's fine as long as you're using the distributive property or something to be able to multiply those that make some mathematical sense. And then we know that's equal to 6x plus x squared minus 5. First thing I'm going to do is isolate the x value, so I need to subtract x squared, and what we'll notice is x squared minus x squared is equal to 0 on both sides. So we're left with a linear equation now. Negative 3x minus 10 is equal to 6x minus 5. We're going to subtract 6x to both sides. It's negative 9x minus 10 is equal to negative 5. Add 10 to both sides to get negative 9x equals 5, and divide by negative 9. So x is equal to negative 5/9. On to part C. Move that one up here. This one we have a quadratic that is not going to cancel out the x squared, so we are going to have to do a little bit of factoring here potentially, or the quadratic formula, or completing the square if you wanted to. So I'm going to first look at the factoring. So because I do have a 1 in front of the x squared, and I go to do my generic rectangle here, I have x squared and negative 15. So I'm just looking for what multiplies to give us negative 15x squared, but adds to give us 2x, and that would be 5x and negative 3x. And so therefore, if this is going to be an x times an x, we'll have a plus 5 and a minus 3. So it is factorable. And that way we are able to use the zero product property to find the value of x equals negative 5. And then also the factor x minus 3 equals 0. So x is equal to 3. So there's two solutions for C. X equals 3 and x equals negative 5. And the last one, part D. 2x squared minus 11x equals negative 3. So just to show you another method, I'm going to add the 3 to set it equal to 0 here. This one might be able to be factored as well. I'm not 100% sure just yet. But just to show you another method, I'm going to go ahead and use the quadratic formula on this one, even if it is factorable. So A is equal to 2, B is equal to negative 11, and C is equal to a positive 3. So adding the 3 to the other side with everything else is important, so we can see the true C value. And so now we can plug it in. X is equal to the opposite of B. So that's the opposite of a negative 11 plus or minus the square root of b squared minus 4ac all over 2a. And so I just plugged in the values as I went along there. And so we have x is equal to positive 11 plus or minus negative 11, quantity negative 11 squared is 121. And then negative 4 times 2 times 3 is negative 24. 2 times 2 is 4. And so now we get 11 plus or minus the square root of 97 over 4. If your teacher wants the exact answer, then 11 plus or minus the square root of 97 over 4 would be your exact answer. If we want an approximation, we could plug this into the calculator, and we would plug in two things. 11 minus the square root of 97 over 4, and that would give us a value of 0.29. And then we'd also take 11 plus the square root of 97 over 4, and that would give us a value of 5.21. And those are the two answers to the quadratic. So now knowing that, because we do not have a perfect square underneath the square root, I would not have been able to factor it anyways, so I would have to use the quadratic formula on this one.